We have not really talked about very much with circles, but we are talking about area and perimeter, so we're going to do that with circles as well. And we want to remind you that the circumference of a circle is 2 pi r, where the radius is the r, or you could use c equals pi times the diameter, so use the d as the diameter instead, but most of the time we're going to do 2 pi r. The area of a circle is still pi r squared. Remember, where the radius is the distance from the center to the edge of the circle. We are going to now go through the two new pieces that are going to be different. And what you want to remember is that arc length and area of a sector is a percentage of something. And the arc length is a percentage of the circumference of a circle. So it's just a certain portion of the circle. It's not the whole distance around. The area of a sector then is a certain section of the circle. So it's a shaded, like think of a pie piece. And it's a certain percentage of the area of a circle. So that's where these two formulas are coming from. Because to find a percentage of something, we need to take the part divided by the whole, and the part would be the degrees it takes up in your circle divided by the whole circle degrees is 360 degrees. Then we multiply it by the circumference equation. So if we're finding a certain portion of the area of a circle, we take that certain portion of it divided by 360, so our part divided by the whole. And then we would multiply that by pi r squared because it's of the area of the circle. So if you notice the similarities with it, the only part that's different is what you're multiplying it by. So if it's area of a sector, you're multiplying by the area of a circle. If it's arc length, you're multiplying by the circumference of a circle. For number 1, when we need to find the length of the arc, we need to know the degrees that it takes up in your circle. We also need to know what the radius is of the circle. So our degree in the circle from arc AB, so it connects A to B, and our circle is 120 degrees. The radius then is our 3 inches. When we set this all up, you can see that I've got the degree over 360 times 2 pi r, because this is a portion of the circumference, or the outside perimeter of our circle. The degree of our circle that it takes up is the 120 degrees. The radius then is the 3 inches. Now, part that you want to remember is you're going to be writing your answer sometimes in terms of pi. That means we're going to reduce or combine all of our numbers together, but the pi will still be in our answer, so we're not going to multiply it by the pi. Other times you might want the non-exact answer, so you could round to the nearest tenths place. When we need to combine the different pieces together, we want to take this and multiply it by 2 and 3. So let's combine the 2 and the 3 together first. That gives us a 6 pi, and that's over 1. Now remember, when we multiply fractions, we go straight across. So we can take 120 times 6, and we get 720 pi. Still all over 360, because 360 times 1 is 360. Now this portion of it we can reduce, and that becomes just a 2. So our exact answer, or in terms of pi, is 2 pi, and this would be in inches because we're dealing with the length. If we want the non-exact, that would be 6.283, or if we want to round to the nearest tenths place, so stopping after the 2, we would put 6.3, and that would be inches. On to number 2, we want the area of the arc A to B to C. So if you notice, this is longer around, it's more than halfway around, so it's more than 180 degrees. That's called a major arc, which we'll learn more about that when we talk about circles. But we know that the angle AOC is 166 degrees. So we need to take 360 as a full circle, subtract the 166 degrees, and that gives us 194. So this outside arc is 194 degrees, and that's the arc that we want. Now for the radius is just 10 inches. And if you don't have that written on your paper, go ahead and write that part down because I added that in. And when we fill in our different pieces, the degree goes over the 360. We want the part over the whole, and then times 2 pi r. Now remember, we can multiply our 2 and 10 together, so this is really 20 pi over 1, and then we can multiply that by 194 over 360. When we multiply 194 times 20, that gives us 3,880 pi over 360, and now remember, we can reduce this part of it. So if you reduce it, you can do it in your calculator as well, but when we reduce it, we get a 97 over 9, and then our answer would be in terms of pi. So 97 pi over 9. Now for the non-exact answer, I want you to write down what your non-exact answer is, and don't forget to round to the nearest tenths place. What you should have gotten then was 33.859. When we round to the nearest tenths place, it would be 33.9, and again, this would be in inches. So would the other one. When we set up number 3, we are finding now the area of the shaded region, so area of a sector. So it's a portion of the circle, and we still have to write down what the degree is in our circle and then our radius. Notice the missing piece is this is the direction that we want to find. So remember, around a circle is 360. If we subtract off the 60 that's already there, we would have 300 degrees for the amount of the arc degree around that edge of the circle. The radius then is our 5 centimeters that they told us. And when we fill in those values, remember we're finding area, so we need to multiply our proportion or our fraction, the part over the whole, times the area of a circle, not the circumference, because now we're finding the area of it. Let's go ahead and fill that in. So the degree is 300, the radius is 5. Again, we can simplify this part of it, so we get 25 pi over 1. And then we can multiply that by 300 over 360. When we do that, we get 7,500 pi over 360. And we can reduce. So always remember to reduce. So we get 125 over 6, and that would be pi. And this would be centimeters squared, is in terms of pi. So when we type that in the calculator, always remember you're using the pi symbol on your calculator, not 3.14, so we would get 65.4, and that would still be centimeters squared for the non-exact answer. For number 4, we have it's almost like a fan piece, but if you realize it's still part of a big circle, that's a really badly drawn circle, but that's part of a circle, and we still need to find the degree in the circle it takes up and our radius. I want you now to fill in what is the degree in the circle, and I also want you to fill in what is the radius off to the side. Degree of your circle should be 144 degrees. Your radius then is our 3 centimeters. When we start filling in our missing pieces, we know that the degree goes on top, so it would be 144. The radius then is our 3. So when we simplify this, we get a 9 pi, and then we can put that over 1 again. We reduce or copy over 144 over 360. Remember, we're going straight across, so 144 times 9 would be 1,296 pi all over 360, and we reduce our numbers, and that gives us an 18 over 5 pi, and that would be centimeters squared since we're finding area. Then your non-exact answer would be our 11.307, or 3097, sorry about that. Stop it after our 3, so it just stays 11.3, and again, it is centimeters squared.